Good morning everybody. Today we will discuss about a concept known as multi-threading in Java. Multi-threading in Java. So what do you mean by multiple threading or multi-threading? Multi-threading is the process of executing multiple threads simultaneously. As the name suggests, it executes multiple threads at a single time. But what are threads? So we need to specify what are threads. So threads are basically a lightweight subprocess. Threads are lightweight subprocess. They are the smallest unit of processing. So threads are basically the smallest unit of processing. You need to remember this, and basically they are lightweight subprocess. You need to remember subprocess. So what are threads? They are basically subprocesses. If they are subprocesses, then they must be contained inside a process. So we can say that threads are contained inside the process because they are the subprocesses. So if there is a thread, if there are threads T1, thread T2 and thread T3, then they can be contained inside a process P. So this is something about threads. This gives you an idea what are threads, where do they exist. What is a process? A process is one that executes. Similarly, a thread is a part of the process, or it is a subprocess inside a process. So a thread will execute first inside a process, and threads are small in size. Threads are blocks of you can say process. Okay, they are the smallest unit of processing. You cannot further divide it. So this is a kind of idea about threads. But why do we use threads? We use threads in order to perform multitasking. And what is multitasking? Multitasking is, for an example, if you have opened a notepad and you are writing on it, and at the same time there is a music playing on your desktop from the background. Now at the same time you are able to write on the notepad, and at the same time you are able to listen to the music. So two processes or two tasks are being performed simultaneously. So this is known as multitasking. So threads in Java are used in order to perform multitasking in Java. But is there a single way to perform multitasking? No. There are basically two ways to perform multitasking. First one is by using multiprocessing, and the second one is to use multiple threads or multi-threads, multi-threading. So in Java you can perform multitasking in two different ways. First one is multiprocessing and second one is multi-threading. But in Java, as you program, the code must not be complex enough. The code must be as simple as possible. in order to understand, in order to write, in order to rewrite, in order to test, the code must always be as less complex as possible. So multi-threading has an advantage over multiprocessing in performing multitasking. So what are the advantages? First of all, we need to discuss about multiprocessing in order to know the advantages of multi-threading over multiprocessing. So what is multiprocessing? In multiprocessing, each process has its own address in memory. That is, each process allocates separate memory area. So when each process allocates separate memory area, what happens is, for an example, if there is a process P1 that comes into picture that demands a 16-bit space in memory, and the 16-bit space is allocated to process P1. The second process P2 comes and it also demands another 16-bit of memory. It cannot share that 16-bit of memory that was occupied by P1. It will have to share a different 16-bit memory. So it demands a different 16-bit memory. This is a disadvantage of multiprocessing. And another disadvantage is processes in multiprocessing are heavyweighted. When do a process becomes heavyweight? A process becomes heavyweight when it takes more time to execute. And when does it take more time to execute? When it is having much more linking between functions, between function calls and return through, and it might be having much more data types that occupy more and more space. So that's why the process becomes heavyweight, because it takes more time because of large space that's occupied in the memory, and it takes much more time in linking between those memory spaces. So that's why the process becomes heavyweight. And at the same time, in multiprocessing, cost of communication between processes is high. So if the cost of communication is high, it somehow means the same thing, that it takes more time to execute. It takes more time to execute or let one process communicate another process. There are times when during the execution of process P1 there is a need of process, let's say P3. So the process P1 needs to communicate to process P3 in between its execution. So here at this point we are talking about that communication, and in multiprocessing that communication is high because the process, each and every process is heavyweight. So the costs of communication between each process is high. And at the same time, when you switch between various processes, it also takes time and is more complex than in multitasking. In multitasking, what happens? In multitasking, threads share the same address space. So if there is a thread T1 which occupies a 16-bit of memory, and there is yet another thread T2 that comes into picture, then it will share its execution in that space, that 16-bit space of thread T1 only. It will not demand a separate 16-bit of memory, or it can override the functioning of thread T1 when thread T2 comes into picture. So thread basically share the same address space, and they are, because they are the smallest unit of processing, they are literally very lightweighted processes. They are lightweight processes or process, because they are the smallest unit of processing. You cannot further subdivide this processing. So they are very lightweight in nature. So because they are lightweight, so the cost of communication becomes low. Means you can easily communicate between processes or threads. Sorry, you can easily communicate between threads because this is multi-threading. I have written it wrongly. Multitasking. It is multi-threading. Sorry. So in multi-threading, threads share the same address space. They are lightweight process. The cost of communication becomes low. Means if there is a thread T1 that is executing and it needs thread T3 for its execution to complete, then thread T1 can easily communicate with thread T3 and let it execute first. So the cost of communication between threads is low, and at least you need a single process for a thread to work. Means it's obviously very much easy and very much time efficient to use multi-threads over multi-processing, but at least you need to have one process working or one process running while you use multi-threading. Why so? Because threads are nothing but they are the sub-processes. So if a sub-process needs to execute, you need to start the execution of the process itself. Then only the sub-processes will get executed. So if there is a process P and it is having 3 threads, T1, T2 and T3, then no matter you can execute T1, T2, T3 at the same memory address, and they are lightweight, they have very much advantage over using processes P1, P2 and P3. But at the same time, at least you need to have a single process that could contain all of these 3 threads inside it. So the process P will contain these 3 threads inside it, will contain it, and will let the communication between these threads and let the execution between these threads execute very quickly, and thus the process on process P overall will execute very quickly. So this is kind of mechanism to perform multitasking. In a way, it is more efficient to use multi-threading than multiprocessing, because in multiprocessing every time you need to perform a task, you need to create a new process. But programming has, as time goes, determined that you need not to create a different process every time. You can create a different thread or a sub process inside the process every time you need to perform a different task. For an example, if a notepad is open and at the same time Microsoft Word is open, at the same time the two processes are executing, two softwares are executing at the same time. The notepad is also executing at the same time and Microsoft Word is also executing at the same time. But you cannot write simultaneously on both the things. Maybe you are able to write on the notepad, maybe you are able to write on the Microsoft Word. You cannot write simultaneously at the same time on both of the things, both of the softwares. So at that time you can use two threads instead of two processes. Okay, this is the advantage of multi-threading over multiprocessing in order to perform multitasking. So that's all about multi-threading or threads in special. So thank you.